So guys, I will be discussing it after the poll. But before continuing the discussion, I would even like to tell you something about the latest offer which is going on right now. Oh, before going ahead with this discussion, I would even like to show you the important slide regarding the latest offer which is going on right now on Unacademy. So as per this offer, you can see that you will be able to unlock 20% off on your CSR UGC net subscription. Duration 9 months subscription is even available right now at the 3 months, like both the details have been shown here. You can use and apply the code that's Anjali A Live as mentioned here on the screen and get the discount in the total subscription amount, or just save more. Even if any of your friends were waiting to take the subscription, you can share this information with them too. So this is how they will even be able to save more. And in upcoming days, so many new courses by the top educators will be starting on Unacademy. So if you don't want to miss them, you can take the subscription and start your preparation under the guidance of top educators. Now let's go back to the question, guys, and let's see that what steps you have to take and how you will be able to get the answer, because it's just a few seconds remaining in the poll now and nobody's answer is correct till now. So I'm just going to continue this discussion too. Even I'm going to show you some important slides like the benefits you will get in the iconic subscription, like live mentorship will be there, live doubt solving, interview preparation, all plus benefits. Okay, and even now the notes are available on the learning app. Same way for the plus subscription, daily live classes, live test and quizzes, structured courses, unlimited access, and even the notes are now available on the learning app, which will be helping you to take your preparation to a very good level. Light subscription benefits are even there, and the difference between plus iconic and light subscription you can easily observe on the slides. So this is how everything will be getting clear to you, and you can easily take the subscription and start your preparation under the guidance of top educators. Let's go ahead, let's start the discussion about this question now. Let's see what steps you have to take to get the answer. If I'm going to talk about this one, guys, you just simply have to consider xpy minus ypx. This is what we had, ypz plus zpy. The expression is correct, even the answer must be. So let's have a look at this part, that how you will go ahead to solve it. So let's consider the commutator bracket of a with b if you have to find. So let me just write it here. I'll be giving you the easiest method to work on this part. Okay, a is what? I xpy minus ypx, comma ypz plus zpy. Now let's just split it one with another one, like whatever pairs you can form. Done? What you have to do next, you have to just observe it this way. And even let me just tell you what is going to be the condition. For example, you take the commutator bracket of x with y, it will be 0. You take it with the x with pz, it will even be 0. So what I want to tell you, like if it is going to be related to some different position coordinate and different coordinates, it is giving you 0. Other than that, if I'm going to talk about the next thing here, that is going to be x with px. Very good morning, Ankita. That will be iota h cut, and px with x will be minus iota h cut, right? So if I'm going to consider x with y, it is 0. It's not giving you anything. X with pz, 0. It is not giving you anything. Py with y will be equal to minus iota h cut, and py with pz will be equal to 0. So I'm just getting one unknown term here, like one non-zero term here, and that is minus iota h cut. and the position of rest of the terms you have to write on one and the other side. So it's going to be minus iota h squared as it is, rest is x and pz. Okay, that's how you have to consider this part. Plus x with z will be 0, x with py will be 0 too, py with z will be 0, and py with py will be 0 too. So here I'm not getting any non-zero value, all are going to be 0, so I don't have to consider any of these values from the second term. Minus I, x, y with y 0, y with pz 0, px with y 0, px with pz 0, so it's even 0. Next is minus I, okay, and that's going to give you y with px, y with z 0, y with py, that's iota h squared. So let me just write it here. Okay, and next is px with z, like what are the two terms remaining? Px and z, their position will remain same. Z is present on left hand side, px is present on right hand side. That's how we will be able to consider it. Done. Now next thing, let's just simplify it. Iota square is minus 1, which is going to be minus minus plus h squared xpz plus zpx. This is what you will be getting, xpz plus zpx. So where it is, if you will observe it, it's going to be our option C, which is going to be the most appropriate option or the answer. Hence your option C is going to be the correct one. Tell me if in case there is anybody having any doubt, we can talk about it then. And if everything is clear, that's great. I'll be giving you the next question. Please let me know, are you ready for it? Should we start the discussion about the next one then? And you can see how easily you can get the answer while nobody has selected the right answer for this question earlier. But I hope now it will be clear and correct to if you are still having any doubt, you can just mention it. I can talk about that point. Let's take the next one, guys. It's here. Options I'll be writing. Okay, let me just see if I can write on the same slide. Try it now and let me know as you will get it done. I'll be starting the poll too, so as you will be getting the answer selected in the poll. Very good, Ankita. Let's even wait for others to reply. After the poll, guys, I'll be starting the discussion too. I'm just gonna wait for the poll to end and then I'll be starting the discussion too. But till that point of time, you can even try working on it. Otherwise, we will be starting the discussion. Very good, Aparna. That's great. Two answers correct, guys. Okay, guys, so in this case, we have to find the probability to find the particle in the interval between minus a by 2 to plus a by 2. So if I'm going to talk about it, it's basically a particle is in the ground state of an infinite square potential, which is given as very good morning, Sarita, which is given as Vx is equal to 0 and infinity for this particular range. If you will see, it is the symmetric potential well because the integration, like the limits or the range has been given as minus a to plus a. So it is symmetric potential well. When you get to know about it that it is symmetric potential well, what will happen next? That's going to be root 2 by L, which is going to be 2a, okay? And for the ground state, it will be simply n is equal to 1, and that will have the cos as the wave function. So cos n pi x, that is 1 pi x upon L. L is going to be 2a here. This is how you just have to consider it. Tell me if in case there is anybody having any doubt now. Another thing is, if we are going to talk about the probability to find the particle in the interval between minus a by 2 to plus a by 2, so you are just going to consider the range. This is the wave function I have just shown you by writing it here. So integration minus a by 2 to plus a by 2, okay, it's going to be square and dx. Okay, this is what you will have as the probability. Now 1 upon a will be outside after simplification, minus a by 2 to plus a by 2. Cos is square pi x by 2a dx. This is what you have to consider. Now cos 2 theta is equal to 2 cos square theta minus 1. So cos square theta will be equal to cos 2 theta plus 1 divided by 2. Okay, that's what you have to consider. Now the next thing is, if we are going to consider it this way, cos 2 pi x by 2a plus 1 upon 2. So what you will get now after completely solving it and integrating this part, it will give you 1 upon 2 plus 1 upon pi. That's how you're just going to get it. And that's going to be your option B, which will be the correct one then. So this is how you just have to do the simplification here. And why we didn't consider the denominator, because that value will be 1, and that's how you can even easily find it. Let me know if in case there is anybody having any doubt, we can talk about that part. And if everything is clear, that's great, great, great. We can go for the next one. Tell me if there is any doubt you are going to have in the previous question. So your next question is, consider a system of two non-interacting identical fermions each of mass m take the potential inside the well to be 0. And ignore spin. The composite wave function for the system with total energy E is equal to I'm just going to write all the wave functions. You can tell me if in case you will be having any doubt anywhere. Try it now and let me know as you will get it done. Try, and let me know if there will be any doubt. Otherwise, I'm starting the poll. You can select your answer in the poll, whatever you think will be the correct. Very good, Ankita. That's great. Okay, try it now. Just one answer is correct till now, guys. So whatever you think is correct, you can select it in the poll. Okay guys, the wave function corresponding to fermions or electrons, that's going to be asymmetric in nature. And now you can see they have given you the energy value. So you will be able to consider it's a 2D like case we will be having infinite square well potential, right? So in that case, you know nx square pi square h square square upon 2ml square plus ny square pi square h square square upon 2ml square. That's where you will have. So how you can get the 5 here? By taking nx square plus ny square is equal to 5. So for that case, you can take it to be 1 and you can take it to be 2 or 2 and 1. So that means nx and y can have this possible combination of 1 and 2. So that means your option C cannot be correct or D cannot be correct because nx and ny values shown there are different other than 1 and 2. But your A and B, any one of these can be. But as I have told you, it's going to be asymmetric in nature. So 1, 2, 2, 1, that's what you will be having here or you have to consider. So it is 1, 2 minus 2, 1. Okay. And that's how you are going to get the option A to be correct. If in case there is anybody having any doubt, let me know about it. We will try to consider that part. And if everything is clear, that's great. This is how we can just proceed further to get the answer for this kind of question. So it is even gonna be in the numerical form like it is given to you here, or you can get it in the form of like expression only. Anyway, you can have this one in the exam, and that's how you will work on this part. It is asymmetric in nature. Okay, Let me know if in case there is anybody having any doubt, we can surely talk about it. And if it is clear, I'm gonna give you the next one then. Try it now and let me know as you will get it done. Even I'll be starting the poll too. So you can select your answer in the poll as you will get it. Here are the options. Very good, Ankita. That's great. After the poll, I'm even gonna start the discussion. So if anybody is gonna even still work on this part and you are trying to get the answer as you will get it selected in the poll. The poll is going on right now. Okay, for this one, what you will be doing, you had the potential given to you which will be helping you to identify the system. The next thing is you are just going to consider that the expectation value of the energy of the particle is what. That's what you have to consider here. If we will talk about it, it's going to be root 2 by L sine n pi x by a. Okay, if we will talk about it, it's root 2 by a sine n pi x by a. Very good, Aparna, that's great. Next thing is you have to find the expectation value of energy, which is n square pi square h square upon 2 ma square. Okay, so what will happen in this case, the expectation value when we want to find, before that we can write the exact expression of the wave function in the superposition of two different states wave function form. So how we will be able to write it, it's going to be root 2 by a. Okay, like sine n by x by a, you know that, but sine cube pi x by a right now you are having, so you can consider it to be sine 3a is equal to 3 sine a minus 4 sine cube a. This is what you will have, right? So you are just going to consider sine cube a value will be sine 3 sine a minus, this will, I'll shift it here, this will be coming here at this point, it's going to be sine 3a divided by 4. What is this value? This is going to be sine cube a equal to this. Okay, if I'm going to talk about the next one now, which is root 2 by a sine n pi x by a. Clear? Now if I'm going to talk about that part, so if from here, if you will see, you will be having root 2 by a is not present there, but other than that the angle part and all of that you will have done. Now in this case, what will happen, I'll be multiplying after writing this complete expression sine cube pi x by a. This is not that a, you can replace it with theta if you're getting confused. Okay, it's just the formula I was explaining here. So what you will do, you will be replacing the sine cube theta value there and you will be putting this value there. Okay, now once we are going to talk about this part, it's going to be a sine cube pi x by a. So a sine cube pi x by a, that is 3 sine, the a I'll keep here, pi x by a minus a sine 3 pi x by a upon 4. Okay, so in this case what will happen, I'm just not gonna have this root 2 by a term, so I'll be multiplying with it and dividing by this. So I'll be getting sine 1 exact form here and sine 3 exact form here, but for that I have to multiply and divide by this part. Okay, just to get the exact form here. So I'll be having the root a by 2 3a sine 1, then root a by 2a sine 3, and 1 upon 4 you can take it common. Next thing is, once you are going to consider this part, you will be having the, that's going to be the probability of finding the particle in the sine 1 state. You can easily get it. Then I'm just going to write the exact expression for you, so that if in case you will be having any doubt, you can just consider it. This is the new form of the function. Now you want to find the expectation value of energy. It will be summation over n E n P n, which is what? It is E1 P1 plus E3 P3. Next is energy of the n is equal to 1 state is pi square h square upon 2ma square. And probability of finding it here is 3a by 4 root a by 2 square upon 3a by 4 root a by 2 square. Because iota is not there, so I can directly write it this way: a square by 16 into a by 2. Just simplify this part, plus probability of energy of the n is equal to 3 state, and the probability corresponding to it you just have to write. Okay, in the same way you can consider it and add those values. Tell me, are you able to get the answer after this step or not? If in case you will be having any doubt, I can talk about it and I can explain that too. So let me know whether everything is clear to you or not. If in case there will be any doubt, we can talk about it. And if everything is clear, then that's great. Done? If there is anybody who is not able to write the next term or having doubt or difficulty in writing it, let me know. I'll be considering that point then. Let's take the next one. Try it now and let me know as you will get it done. I'm gonna start the poll too, so as anybody will be getting the answer, they can select it in the poll. Very good, Ankita, that's great. Only one answer is correct till now, waiting for more. And after the poll, I'll be starting the discussion too. So Hamiltonian is given in classical mechanics. They are saying what it will be in quantum mechanics, right? So it means if we are going to talk about this part, it is H is equal to omega xp, right? If we will talk about it, see, in the classical mechanics, we don't deal with the operators, but we deal with the like operators in quantum part, right? And then the sequence or the order matters there. So like xp is written, even if I will have the px, it will have a different meaning. So it is in classical mechanics. I want to consider both of them the terms in quantum. So I'm going to consider it, but I'll multiply it with 2 and divide by 2. I'll be getting xp plus px. This is how I will be able to write it. In quantum mechanics, p will be as the momentum operator. So when I'm considering them to be operator, let's say I'm going to operate the Hamiltonian on psi. So it will be omega upon 2 xp plus px psi. It is going to be omega upon 2 xp plus px into psi. So that's going to be x minus iota h squared delta upon delta x, this is the momentum operator value. To show it as the operator, I can even put the cap on top of these things. That's even all right. But if you are just writing it in general and I'm telling you that, okay, I'm going to consider them to be operators, you will be getting it clearly too, like, okay, these are just the operators we are going to have. Okay, x and then psi as a function of x we will be having everywhere. So if we are going to consider this part, it's going to be psi as a function of x. Now next thing, if I'm going to consider it, this is as the first term, this is as the second term. So when you will open the bracket and you're just going to operate the differential operators there, same way for the first part. So what you will be able to get, that's what we need to observe. So it is going to be omega upon 2 as it is. Okay. X iota h squared with the negative sign. Let me just write it outside. Another thing is x delta psi upon delta x. Next is going to be first term as it is, second term differentiation with a positive sign. Plus second term as it is, first term differentiation. So we will just have the psi x here. Everywhere, like even the sign, you can write it as psi as a function of x. This was a plus sign here. So you are going to get minus iota h squared upon omega upon 2x delta upon delta x plus 1 psi x. So from both sides you can remove the psi x, because there you had is the h psi x. So you will be able to multiply inside the bracket 1 upon 2 term. You will get minus iota h squared omega x delta upon delta x plus 1 upon 2 psi x. Okay, so this is going to be your Hamiltonian operator. What you had corresponding to that in quantum, you will have this part. So let me know if in case there is anybody having any doubt, we can consider that part. But if everything is clear, that's great. Tell me if there is anybody having any doubt, we can talk about it. But if everything is clear, then that's great, great, great. We can take the next question then. Try it now and let me know as you will get it done. I'll be starting the poll too. You can select your answer in the poll as you will get it. But in case if there will be any doubt you will have, you can surely mention that part. Very good, Sarita. That's great. Very good, Ankita. That's great. Very good, Shivam. That's great. What about others? Only three answers are correct till now, waiting for more. And then we can continue the discussion about the next one after considering this one here. Or if in case there will be any doubt anybody will have in this part, we can even talk about that. Waiting for more reply. Okay, let's talk about it. For the harmonic oscillator, the standard potential expression is if it is isotropic, then omega x and omega y will be equal to each other. But in general, it is half m omega x square plus half m omega y square. So what will happen in this case? X square and y square will be like separately present. Half m will be separately present. You will just have omega x and omega y. So omega x is equal to omega and omega y is equal to 2 omega. That's what you have to consider. So nx plus half h squared omega x plus ny plus half h squared omega y. Now what they have asked you to find, they have asked you to find the energy of the first excited state. So for the ground state, nx and ny will be taken as 0, 0. For the first excited state, you will initially increase the omega x coefficient of n. Why? Because this is omega while this one is greater value. So it will be giving you more higher value if you increase the second term coefficient. So this is how 1 comma 0 you will take, which will give you 3 by 2 h squared omega plus it's going to be 2 by 2 h squared omega. That's going to be 5 by 2 h squared omega. Please let me know if in case there is anybody having any doubt, we can talk about it. And that's how your option D is the correct one. Clear? Let me know if in case there is anybody having any doubt, we can talk about that part. But if it is clear, I'll be giving you the next question then. Just check it out. All the steps we are taking and how we are proceeding further to get the answer. If still you will find like no, something is not clear to you, you can tell me. I'll be trying to explain that point to you then. A particle of mass m zero to a try it now and let me know as you will get it done. That's great. I'm gonna start the poll too. You can select your answer in the poll if you're getting it. Very good, Shivam. Very good, Sarita. Very good, Ankita. Three answers are correct till now. Very good, Agravat. Let me just tell you this, guys. So basically, it's a 3D case, okay? With the potential expression given to us, we can easily consider it's a 3D cubic box or 3D potential well. And other than that, the energy expression is given to you, which is 14 by 2 pi square h square square upon ma square. So nx square plus ny square plus nz square is equal to 14, which is 1, 1, 2, and 3. 3 3s are 9, 2 2s are 4, that's 13 plus 1, 14. So you will have this with 14. So 1, 2, and 3 you will be having as nx, ny, nz values. If you will see, it's here. Other than that, all other are going to be quite different nx, ny, and z values. And this is how your option D is the correct one. Let me know if in case there was anybody having any doubt, we can talk about it. But if everything is clear, that's great, great, great. So let me know if there is anything which is not clear to you. We can talk about that part. And if everything is clear, that's great. If energy expression, the steps, the process, anything is not clear, you can just mention it. We can talk about that part. For this question's answer, you will be mentioning it in the comments directly. I'll not be writing it. Oh, I'll not be showing you the poll for this one. I want you to write the answer in the comments once you will get this. And if somebody is there who is not able to get it, after some time I will also be starting the poll then. Okay? So you can wait for that time. Yeah. If you are getting the answer, just mention it in the comments. Otherwise, in just some time, I will be starting the poll too. So those who are getting the answer, write it in the comments. We'll be telling you what will be the correct one. I'm gonna start the poll now. So those who are not getting it in the comment section, they can select it in the poll. Means they are not able to write any answer, then they can select it in the poll. Very good, Ankita. That's great. Very good, Shivam. Okay, guys, let me just tell you. So basically, Hamiltonian is the total energy. Energy is dependent on n. If you will see, n values are same for all these cases, so it will be remaining same, and it will be the eigenfunction for energy or the Hamiltonian. The second thing is L. L is dependent on the small l value, which is the second position. It's even same. The Lz is dependent on m. M h cut, okay, for Lz, so it is 0. That means this term will not be present in the Lz case, hence your last two terms will be there, and this is how you will be able to consider it, that your option like Lz, for that it's not true, but for other two cases it is. So h and L square, which is option C, which is going to be the correct one. Very good, Agrawat, that's great. So I hope, guys, each and everything we have discussed here in the session will be clear, and we will be having more and more important sessions in upcoming days too. So right now we are going to keep it this much. I hope each and everything we have discussed in the session will be all right and clear to every one of you. But in case if you will find that something is not clear to you and somewhere you are having any doubt, we can surely talk about that part. Thank you so much everyone for joining this session. Also, guys, here you can see the information about the latest offer, which will be helping you to save more and to get the discount. So you can use and apply the code that is Anjali A Live as mentioned here on the screen, and you can get the discount in the total subscription amount. And even right now the 9-month subscription is available for your upcoming exam, like which will be I think in December. So if you don't want to miss it, this is just a short time or limited period offer, so you can take the subscription or let your friends know about it too. Okay, and you just have to use and apply the code Anjali Live to get the discount or to grab this offer. Anuradha, I have posted about it in the community tab too, and at the all other places wherever I post, to let you know about the session. Okay, and soon you can expect it to be there, the next session. While tomorrow it may not be possible, or let me just tell you. Give me a second. Today in the evening time, I can try to have another session, or otherwise in upcoming days. Let me just see rather whether it is possible or not. Give me a second. Will 7 p.m. work for you today? Guys, do you want to have a session? Then we can try to have the session at that time. Okay, we can try considering it. Let's keep it this much right now. Thank you so much, everyone. Yes, Anuradha. Thank you so much, everyone, for joining this session and for attending it till the end. Thank you, thank you, thank you. Don't miss this offer too, because in upcoming days, so many new courses by the top educators will be starting on Unacademy as well. Thank you, everyone, for joining this session.